Dr. Jayakanth, Assistant Professor to Telakada, Fundamental. Now, today I'm just good morning, madam, and a good briefing on vision part in complex environments in all those inputs. So, the idea is the vision factor for any of the navigation and so many perspectives. So now we are going to look onto the robotic side. So when you look for the robotic side, so how we are going to use multi-sensor environment for a robotic. But when you look into this robot and we are having some classifications. So one of the robot basic history, and then the technical part of robot and sensing, and how the motions are being developed, and what are the applications, and how we are going to implement. What are the works that we have done. So generally, just for your representation, we are given the different robots, worldwide, how they are developed. So basically, when you have it's more onto the focus area, what robot does. So when you say as a robot, what's the purpose? Why you are going to use it? So that's the main intention. So you're combining with multiple domains to implement with a particular task. So the task is what you're going to give. So how the name is being framed. So the first thing, it's a Czechoslovakian dramatist. So they used the term robot in 1921, and robotics was specified by the term by Isaac Asimov. So it's in a fiction series book in 1940s. Uh, so generally, a robot is an automatic general purpose device which primarily functions to produce a motion in order to accomplish some. So that's the main objective for a robot. And defined definition, an industrial robot is a reprogrammable, multifunction manipulator. Specialized devices from the book, and then with that's in 1922. 1952. Yeah. Nowadays, when you are taking out to your so, nowadays, we are going for more specific tasks. Am I audible if I just speak the last? So you have when you are going for a development, so with all these factors, uh, so we started with the development. So the basic thing is uh, where the robot is going to be used. So when you say that, this is the four phases of so basically the robots were not for any new task or something that is unique they want to do it. But the purpose of the robot is to deploy in a dangerous environment or with some kind of difficult task, generally with the dull. Why we say it as a dull is the repetitive work that you want to do it. So in industries, we keep on moving with the same task with this high precision. If you put with a human end to develop the use for a particular work, it takes they get tired and the efficiency is not up to the range. So that is the first thing they started going for robotics. So they want to improvise their production capacity and then enhance huge profits and margins. Then one where we are using for a toxic environment or a dirt environment. Suppose some gaseous substance will be there. If a human goes in and he may have a lot of difficulties, even some loss of life have happened. So to avoid all these things, they went for the uh, deploying with some specialized robots which can do some cleaning or any kind of the task. So the task depends on how you want to have it. So what is the perception and what purpose you are building the robot? So that is very important. And then with any difficult jobs, suppose you want to use in a nuclear reactor. So how I want to use with my bots and bomb diffusers. So everything we can deploy with multiple different sets of bots. And nowadays we have the robot surgeries. So the surgeries are more like high kinds of surgeries. Or any surgeries or any kind of surgeries, the hospital put a team with the robotic surgeries. You can find most of the hospitals in China. So they use it, so, the basic knowledge, the robot is not follow anyone. So, customer develop in the follow the robot perform in this environment. Because it is not half other and it should complete that how the human give the instruction and it has to protect itself from the harmful environment. So, it should not take up a human stuff. It should be a human development, but it should support them. That is the primary motive. Because a kind of support environment, yeah, going on. So when you build any of your robotic robots as well as the automation end, you have to follow all these things. And the final thing is whether it is feasible. Feasible. Because I cannot build a robot and deploy it, and the cost should not be too high. So I have to, the cost should be a very optimal. So it should not have very high cost in manufacturing it. So all you have to take into consideration. So you have to go for a co-innovator, co-worker, co-explorer, and then with the co-defender. So all it's this kind of thing like this. So you have to suffer with the environment to so this what we are looking at. Essentially, logistics, manufacturing, medical surgery, rehabilitation, animal resource, transportation, monitoring, all we are going to use it. So when you say that we are going to use it, basically, my robot, our robots will consist of generation part. So you'll have the that's what the hardware. So most of the report has to the actuation side. So you have electrical will be what is the hardware environment, but that hardware environment will be common area any kind of commodity devices. That will be controlled and given to so if you give to someone is going to perform in the real world environment. So you need to go for the so something is there, right? When you want to implement any of the bots. So here, while we are doing the vision and robotics, here the vision is going to be our sensor. Vision is not just alone doing the vision input. So that's not the information level. So that's why we are focusing more on the vision side, as well as with the different sensing capabilities that we can do. And how the user requirement. So user will be here we can find it. So normal pitch, the user can do. So the actual human, so the will be different about us. So this will be the credit of their arm. That's why model number um, right? My product quality should be. So all those information I can have it. So I can have my visual inspection and then decide which part I have to accept and which I have to accept. You don't know dimensions. You will be what? Important people. Put with some angular movement. I want to lift the base of the bar. The base and then you can do it. So I'm going to use the apply to the and do that continue on this one. But I can use some extra. So I can use some 150 degree also. If you have access, if it is this, and if you use one different this way, I can use from 150 degrees. So that is the limitation that we have. So likewise, any technology you design at, you have to take into considerations. So we cannot really go and you can have any kind of movement. So, depending on your rotation sequence, and then with your conformity to the linear one. So, along the axis, I can move it, give it a movement. So that's the part one. If you have these connections, so one of the link. So joint connections generally usually have the link. Well, the kind any other that you're going to look at. And that sequence will be movement associated with the period now. That agreement, I will move on. So that's the end of the character. Generally, if you have a linear joint already, I can deliver. So you can do it anywhere with the axis itself. So I'm going to repeat it and this is a very important area of hardware design. This is the standard application. Like selected companies that you know. So this is not widely used in the assemblies in the industrial side. So general configuration is this one. And mostly the affects the group of electrical dynamic and then we give it to one. So configuration I say the joint variables. So this is important. When you say that the movement associated with a joint. So how will we give it here? Suppose I have with the elbow end, I'm fixing a motor. Suppose I fix a motor like this. So the motor gives it movement. Give the momentum to make with your movement. So when you take as the physical condition, still now what we are seeing is the physical component. But what we are going to do is we are going to give a control on it. So when you give a control, you are going to power that device and then give a movement. So that movement, if you would generate, that we call it as a degree of freedom. So based on one particular joint, this is the movement that I call it as a 1 degree of freedom. So one movement, if I could make with one joint notation, that we are calling it as 1 degrees of freedom. So, same way for doing the rotation, so the Q and so regular joints, how am I going to take into consideration? Suppose this is my link which is going to work on it. So this is movement gain, and this is the fixed support or the base link. Either it may be a base link or with a joint, or even it may be a floating environment. Maybe the previous link you can have it. Suppose if I have some 5 degrees of freedom, I'll have multiple links to use it. So in that situation, I have the joint locations here, and how much angle I'm going to move along. So this will be considered. And what we can move. So we can put on all of the we can put on the language, you know, we can put on it. So we can so if you want to have a sensor, you have more articulated movement and it should not impact the other components. That's why the first class, it should not impact the human as well as even the other robots. So that's not more priority. The prismatic one, we give it along the linear movement. There's a general description that represents how the movement is being done and what is the displacement you are able to move. How much distance I can cover. So all have some constraints. So you should be very clear with your hardware constraints because you cannot directly program and then do it. You should know about what level it can do. So that is very much clear. Then the displacement is based on the relative to the previous thing. So by using with all these things, you can if you take with this one, this is a prismatic movement. So linear coordinates. So my movement here is all based on the linear one. So all three linear coordinates I'm giving it, and that we call it as a Cartesian one. So the Cartesian generally we give this as a Cartesian coordinate system. And taking with this one, where it is going to work on it, and what is its volume, what volume it is going to take. So that's what we are doing with the area. So how many work volume it can do it. Suppose this is my table, and I have my board here. So if it could move within this structure, so that we call it as a work volume or work envelope. We can say any form. And it should work only within that environment. So when you go for an industrial use cases, and if you build with your design, so you have to look for the other environments. So one is that where it is going to deploy and how it is going to whether it is going to disturb other environments or to take within that defined space. So that you have to give it. And the cylindrical one, so it will have a linear as well as with the cylindrical movement. So it moves up and down and then with the rotation sequence. So if that case, so the image vector is what then already two line is there. So my work environment will be from the two line to the outer edges till this end. So that's it. They can work like a human. That's this is the loop step. So these are all the configurations we are giving it. But at the end, what it is going to do? So suppose you are here, I pick a paper. This is paper. So this is at my loop step. So this is what how I can go for my tuning. So when I say that, the loop end also implies with how a human does functions. So we can, if we are able to make a movement like this, that we call it as a pitch movement, pitching movement. And then with the sidewise movement, if we could give it, that is with the yeah. And then if we keep going with the rotation along my arm. That is my role. So first, yeah, and then the three major factors in designing the clear rescue. So it is not necessary that always we should have all the three movements and clear overhead. So the principle is clear building. So you can see that I'm going to give this movement. You have to take the design consideration for your application. Suppose if your application requires all the three movements, then only you have to take into consideration. Which means you have to take either one of the movements. Because the robots cannot load it. So you need to look into the consideration of loading. And that you can fix the motor to reduce can and you can start moving it. That weight will also add up. Suppose I will be able to fix some tool at my and that will have a considerable weight. And that will impact the other movement. So I want to take one of the independent weight and this that I have to decide my other motors. So we can quickly go with going from the arm to the you have to consider it to look into the arm. Look at the arm. 2 kilograms of load are finished and bricks are higher than the bricks. So these are the two calculations. The root configuration is the end of output. So that's what we are going to see here. So this is the end of form and then this is the movements. So here we are moving with the electromagnets. So these things are called industry use cases. So if you want to go there, you just engage the power and then metal part or something and this is not going to some other thing. So we do here normal group current and and then automatic robots and mathematics. This is gas. So we have the computers and we use the vacuum robots to move it. So all these things are very important. And remember, this is the thing, 100% of the food. So you can have a cutting tool. You can different make cutting tool to make manufacture. And you can send it to factory where you can special cylinders and move to any extent and you can do it again. And you can open this manually when you go to the cutting end. You have to fix this and then they have it. But I'm going to show some simple cuts which can rotate and then able to move it. So you can use the move it and can work at any extent. So this is kind of extension of the works. So whenever you are giving flexibility to the robot. But when you have the counterbalance forces, the based on that, based on the investigation, they decide on this factors. And then another thing to grinding. So all kinds of similar approaches. So I'm looking at some finishing, the polishing end, surface environments. So we do that, this kind of standard configuration or artificial development. So this can go to any extent, and then use the good finishing as well. So that's the benefit. So that is factor. So we are something related to calendar, depending on your application, plus a menu will be over. Very easy. We say that I want to ability to happen. But the reason is good understand. And one point we can apply on it. Three factors. So these factors you have to calculate. And suppose I hold it, and if I lift it, I'll still move instantly. Our fingers will hold little tighter because that should not be initial. So if you look at here, you can force speed calculation. So what we are going to happen, now we are going to keep the number. So that is very what is the rules for the number. And that's when you use the object, how many remove balances? Because nowadays, if it is the mobile one, then not become somebody different factors, but if it is the mobile one, so you have to see whether they are using the automation or bypass or any part of it one. So what type of application that we are going for. So that is the next criteria. And you have to calculate the robot structure, basically, and remember the arms will influence the content I want to trigger. That calculation also will be taken into consideration. I mean, considering it is work volume also. So, to get here, you have to design the here engine and not three equal pattern. You can do to bring water out of the higher case. Because we should not be more specific control environment movement. What is indicated? What is the kinematics and what is movement that you are indicated? So, by taking that into consideration, the first thing is the perception. So, I mean, actually needed. So, you have perception concept. So, that's the perception. And for that, then we have need and the better one, we have the quality. The power by inside and then the vision side. And we need to take into consideration. So, this quality is built on the body. So, going to this could be actually virtually applying. And now we're going to get into the actual side. So the actual side, so it's a different perception rate. So this very important medical consideration. Because I'm trying to catch whatever you're saying. Okay. So when you just slow down, right? So that is number. As I said, all these things. So normally, our model, the tools, the sensors, and not there. Now I need to integrate all together. So I want to make it as a complete product. So when you want to go for a product, so I'm completely depending on the control units. So the control units are very volatile in any of the robots. Because you're going to have a complete control environment in the mechanical moments. So when I say that with yes, so when you have to do this, you have to deal with the this these cycle and board and also the visual plasma. So these things are you can continually using it. So when you know that there are things you have to do corresponding developments, connectivities, and then with the controller and the planning units, everything is there. So how we are going to do this? Suppose I have online activities in the industry. You may complete so, using with your robot side. Vision inspection. what we have to take into consideration. What are the feedback you are going to give for region building? This will give us actual input how your individuals use the data. So, without that is what hardware part. And now we are looking into the robotic sensing. This is very important because whenever we are looking into the data implement. So, when you say that sensing, so it's like how to use it in a particular environment. Suppose we are in an area, suppose I'm here and many, some 40 plus person, they are listening to it. So that is the initial intention that we get on top. But those inputs are not possible for a machinery. So that's what we are taking on all those input to create as a functional form. So how in real world environment the sensing happens. So I can classify into two things. One is that extra subject that is the environmental monitoring. So where you are and how the environment is being there and what needs to be monitored at that point. So that is with your extra subject and pro sector was with self state. So that is taking on the robot itself. So one of the things that it is going to take on considerations. So these two are very important when you want to sense it. So in here is where the most of the sensing devices super important. So when you start doing the programming, suppose you are developing an application for a robot. So you need to be very clear how you want to use all these things. So before the environment is you need to you know that. So, FXM, and the local efficiency, the local environment. You have to allow to data. You have to do navigation, you have to give it. You have to do interaction, you have to make what environment. So those are the environment is important to take into consideration. And the second type, the unit internal costs. So it's kind of suppose if you know, suppose what are the conditions we have to give up. Removal criteria and then suppose the case of rotated speaker. So if you move it, then one the next sequence on the board, then the group is available. So whether I'm going to work on a classroom or I want to make some other activities, so that is within the class. So whatever you are building it, you have to connect with that. So that's this. And mostly when you say that you're going to explore the vision and multimodal sensor cases. So that's what we are currently using it. So when you have complete experience on the vision side, so that's very much needed. Here, if you go right, you can maybe video on the robot, meaning that you can use some interface based on the visual input, the visual perception. So this is one major part. Most of the research ending with the industry use cases are used in the visual side. So generally to develop RGB or CM adapting and this depends on the feature resolution and how it is going to build. So first, here goes the RGB one, robotics here. So the teaching of it. So now I'm suppose assume that your eyes are your cameras and then you are focusing on your environment. So I find a bottle here or a laptop here. So on multiple environments I'm recognizing it. So this you'll do with the visual perception. So vision module you'll do with multiple things. Suppose I want to pick a pen or marker. So I'll just look for the environment. So if the marker is there, I'll go and pick it up. So the vision says that so some environment that I want to identify. So my requirement, the intuition is I want to pick my marker, so I can pick that one. So I have with an environment. So I have my the divided parts. So if I have with this view, so that we call it as a single view. Even I have a projector here. So this kind of projection I have it. Suppose this projection I'll divide into four quadrants. So the quadrants, if I see like this, because I'm standing here and then I have a field of view, it's in this one. You have to identify which quadrant is market is here. So if it is on my the fourth quadrant. So how I have to give my control environment to my mode to pick my market. So that is the factor. Because I have to accomplish a task where I have to go and pick my marker. So I have to make my robot to move towards that direction. So in that sequence, I can decide at some the first less both minor variances of X and Y. Because I'm seeing the 2D view, not with the 3D view. So if I identify that one, then I have to give the robot control to move over the direction. So if I want to move along with that direction, I have to give the motor control. So the motors will be there with your robot, but that motor, how I have to turn it? Suppose I have to go for the quadrant end, and then I have to move. So if I move with some few centimeters or few mm, then again my the camera input gets recalibrated because I'm moving towards that one. So it keeps on recognizing whether I am focusing towards that or not. Suppose my robot moves towards that and I'm getting onto my center axis, home position, zero positions or something. So I'll fix that as my home position. Then I'll say that I'm near to that one. Then my arm will just pick it up. So these are conditions you are using in real time you are implementing it. But the base idea is only with the vision in we are going to take it. So the vision perception, how you visualize and what are the things that you are going to bring it in. And based on that, your movement control should happen. So this is very important. So you can go with either with the camera never bothers about that. So this depends on what camera we are, what are the condition we are going to deploy. So you have to choose the right camera. So I mean, you have to choose, suppose I want to have the normal lighting, you can go with the normal one. RGB, basic one, solution, everything you can go for. Suppose you are going to use a night vision, you can go for a night vision based camera. And then so it all depends on the application. So that's why select the application properly. And for that, design your hardware and even if the camera and sensing you have to design based on that. So if you don't design based on the normal organization bodies, the application will be right away. So there is another Applications. So we use this business like so many areas demos with how we are going to use it as well. And because this year, this should be getting and if you going to learn. So if you think that this is I have many questions that one minute. But if it's good for the continuous rotation level, it is not really good. One thing you can go and then get back. So if the 3 weeks a week rotation again, so doing it right, we have real things. So we've got most of the automobiles and we have a electric cruise control and so many things are using the modern cars. So they use that. And this is the ultrasonic one. The same thing, transfer and ready, the water goes fast and then it reflects back and then it reveals it. So the behavior transfer, transfer, click the button, and then get back. And this identifies what is the benefit how much time it takes to travel and then return back. If it identifies the distance measurement. So if it is the distance measurement, based on the distance, you can measure it. Radar is also for stop. So I know this kind of conditions like a parallel and question. You can have multiple things. You can everything like that, very impacting something. So suppose I want to fit part, manufacturing part. So we should have this kind of vision. So you can do, and then you can go back. So then hardware is just kind of suppose I want to have it things. So you can directly just like it back. And if you can touch, then you can go for it. Even the physical things. Most of the using it. So what happens with the tension in the capacitance between the plates and that gives you sensory output. So that's why it is getting the visual value, the screen area. Because if I have this as a touch, and if I click on this, that actually gets manipulated and that mapping is giving from the hand input in house or any factory building. And that creates a applications or any other thing. So you can people are trying to what it automatically opens it. So the application we are enabling it. Yes. So it is not very big as well. So they are 50 humans. And in that we can do it. Or Most of the surrounding factors environmental factors like weather, any conditions, and then the weather. So people can nobody has something possible. The same way here also the analysis of efficiency. So this is very vital. Like how do you move for a robotic application? Same way, in the use of AR sensors also, these sensors are very expensive. And will give some good solutions for it. But really, solutions need to be appropriate and consistent. I cannot say that I have to use only so many things on it, but based on the need, we have to go for it. So one thing about the statements was taking up with the image perception and then control. We have just taking about the motions here because initially it was when you want to know that to move, the motions are very important. So mostly we deal with the dynamics. So when we do this, that relates into kinetics and kinematics. So you see it as kinetics that deals with the initial movement of the body. So this is the kinetics, right? So when you see it as a kinematics, which deals with the relative very important. And this is a marker. And this is the way water movement will make environment. So, if you want to move from the time space to the condition space, that is considered our kinematics. And the condition space to the time space, that is considered kinematics. So, followed by kinetic kinematics. So, generally, including the limit and then the angle. So, this moving coming to over and there's a fixed support and this movement can go to based on the previous one. So I'm going to give it and giving it movement. So that's what you know, functional robotic and robotic, which is very good. So here with this, we can here is my daily location and this is my arm and this is my gripper or any tooling. So if I want to go this level one, if I need to make mathematics, I will X select. So what is the length of the link and how much angle it will be now. So the element X is the element of the data. So basically, during the allocation of that, you have to consider the give the meaning. You have to move it here, so this is very important. So we cannot just go and say that this is about the values of the mind. So you have to take into all the considerations. And even if suppose I am fixing up with this point, and to that I want to know how to take with the value, I think the value is of advice. So that I can do one by. So generally, the degrees of freedom will be calculated using the Laplace equation. So, whatever moment and the going to give it, 3 into n next question. So, we will be equivalence. That's the one of the T, and G is the number of channels at this particular record. So, this determines your equations. So, if it is one and one, and if it is able to give it the most of the values, factors, then it shows that there is a value part. Because if the joints are low, then the links or something like that. And if you could not know it, there is no conflict. So if you have here links as well as here joints, which can satisfy this one. So normally you have positive values. If you get with the negative values, you are not happy with the bottom percent. So if it is a positive one, that is actually not really negative. The spatial manipulators, that's the serial manipulator and the other manipulators, functions like this. If 6 into n minus 1 minus fp1 minus 4p2, it's closer up to p5. So that will be number of times n and the number of joints and parts of one division and increasing order of the divider equals to that. If you use satisfies, so that gives you good result for your parts. Consider equation for parallel matrices. This was the stated posterior divider and this was the parallel matrices. So this is the minus 1 plus 1 to 3 that is to the advance and the number of things. And this gives you here the individual ones having the iron being here. So this is very important because fixing habit is only the you're putting up with the past. When you do for this, you can fix it. Yes, so that's one of the positive values. If it goes to the negative one, then again it is not a suitable condition. So going with that further, it's a really one. So we are going to get most of the thing we give it a really good. Now it is going to get whether it is with your steering direction control, and extra force against the ground. And generally the ideal values perfectly wrong on the perimeter that you have taken, moves in the direction equal to the axis. No intersection. So this is very important when you want to go for it. And this is the contraction is the hard factor that is being removed over. So there is a rotation that we are going to do over the simple. So this is something that rolling happens automatically. This is going to be the one that is no one.
When we encounter boring situations like this, it has
Structures. So now, when you think about the robot movements, you are completely putting on the rigid body structures. So not going with other considerations. You have to look into the rigid body structures. And you are taking with your reference. So taking with your initial course, my questions, gives me X and Y coordinates, and I have my angle with 0. That is the initial state. And when I go for the time transform, then knowing that I'm varying velocity is P of t in the direction theta of t. So my positions, how would it come? X of t is 0 to 1, et cos t cos theta dd, and then y of t sine, and then the angular velocity. So for this, the force estimators is represented the robot state in 2D plane only, and orientation are taken in it. And the initial force starts at zero only, but it goes with that. So this is the velocity calculations that you have to do for any of the movements. Okay. So simply going with your vision, uh, same way taking with your vision model as Nam said clearly with the vision, so that we have as a model. So based on my analysis, this is the lighting is how you light the device or the object that you want to do. And manufacturing system, you have to take into consideration. And what is the vision that you are going to analyze, and what is the decision you are going to do. And based on the decision, your actuators should do. My robot should perform only based on the outcome of vision. So this is with more specific application where you will implement the vision with your robots. So this is with the instruction. So how they do the model binding, the vision and how they analyze it and what they identify, analyze, plan, implement, and they have instructions. So a few examples we're doing it. So going with the data sets and not only the data sets, the real-time data and how to train it, and how to train product that we're going to do. There are already strength and visual one with the robot control so that you are giving it. So you can have some few examples from the industrial setting. See here, there's an industrial environment where the operations are they're doing a machining operation, and here the person is also there involved, and you have to consider the object and how the tool is there. So how this kind of code works. So how the humans also collaborate with the missionaries, and how the visionary input gives a complete real-time application for environment. And this is kind of measurement analysis, methodological data. So suppose they manufacture a coil spring, so they'll identify it with the measurements. What type of dimension the coil is having it, and that gives a note. So these are the labeling and the part assembly. This is the first thing you're seeing it, right? The identifying with your whatever it is. If you want to visit, you can use an accurate code now. You can use, for example, if you have the start of so how to integrate with multiple systems. So the internet of the class, very productivity, comes from the condition. Because the is very and also. So the is we are dealing with the true works one. So using for an industry use case, how we can give it some solutions. So there's this kind of PPE equipment, that is personal protective equipment. It identifies whether the person is wearing the required setup. So this bot will go and stand in front of the person who enters it, and that will identify whether he is having the mask uh, or with a cap or a gloves or something else. So if everything is fine, it gives a status verified and can work forward. So this we are doing with currently we are working on it. So analyzing with your mold orientation, the image perception of how our human hand gives it. So what are the questions that we are giving it? For that we are able to we are just made with a simple fabric type arm. So in that if we show that visual input, so that identifies what you have to show about. And that's what we are currently working on. In the school mode, we are using the custom further. And this would be made and going for some competition. This completely built by our students. So they did with your complete analysis, uh, development, board, sensors, everything. So, so this was you can have questions, you can ask them. Yes, any questions? Yeah, I'm seeing that. Actually, the combination of different access so that's been amazing. It's like different. See, in this, we have different requirements. So depending on the requirement, we need to body it. We can have a clinical process. Because if we have a clinical science, we have a it's only how balance of it.
Yes, yes.
So that is
So like one circle and two linear.
yes, it becomes. So the people we are needed.
That's typical ideas.
Yes. If you like them, you know, it is still one that structure. Yes. But yes. We need to give it the moment. The moment from the yes.